I really wanted to make you calculate a big molecular weight, right? I did the easy ones where I didn't have to calculate much in the way of molecular weight. I just looked up there in the periodic table. So I can give you any one of those. And I was going to go to the web page here. Home page. This is one of the ones I always get a lot of complaints and say, this one doesn't work, it's not giving me the right answer. Oh, wow. Well, let's do one. New problem, there we go. Gives you calcium fluoride. Okay. And it says you want to calculate KSP, you want to calculate the molar solubility, you want to calculate the concentration of cations and anions. That means one of the biggest problems people have is they don't know what the cations and anions are. Just like when I give you one of those little lab quizzes and I say, write the formula for the complex ion, and people write me things without a charge. If I ask you for an ion, there better be a charge. Okay? So you start this off the same way. Cation. Anion. Okay? Now, here, I'll do the I, and this is going to be dash, or, oops, I want the C thing. C minus X plus X plus 2X. Same problem that we did before. Except X is the molar solubility, he gave you the gram solubility. And you say, okay, 7 times 10 to the minus 3 grams. And you want to convert that to molar concentration. It's going to be molar concentration of CaF, this number right here, that X. And by the way, a lot of books put an S here and X is over here. I don't know why they want to do that, but you can do that if you want to distinguish for solubility or remind yourself. And you look up there, calcium 40.1. 2 fluorines, 38, 78.1, and they go along and they don't get the right answer because they didn't read this. He's not giving you the solubility in a liter, he's giving it in 0.1 liters. And people miss that. They get everything right, except they don't get this column right, or this column, and then they're in trouble. Okay. So that gave you the concentration, that actually gave you X, then you can write in the calcium ion, it's going to be the same number, fluoride 2 times that, the anion, molar solubility, that's what I just calculated here, and then KSP is going to be the other thing people forget, you're writing the KSP, this times this one squared because of that 2, so you get 4x cubed. And I think somewhere does he say, I think you should carry 3 significant figures because, again, this one is sort of sensitive to the number of significant figures. It's like that one with the orders of reaction. You get the orders right by rounding off, but then you go to plug it into the equilibrium expression or into the rate equation. You sometimes don't calculate the right number. Okay, even though it's the same number he calculated, he didn't like what you had here or something. Okay. So I think this one is sensitive like that. The quick way to do this is just to make sure, if you want to see what he did with significant figures, show answer, and down here, this gram formula weight. In other words, he uses gram formula weight instead of molecular weight, but he has grams times 10. In other words, I put this in the denominator, he just multiplied the mass times 10 so we could get the amount in 1 liter. Same calculation. So I was looking to see, he was working with 3 significant figures all the way, so that's what he should do. Yes?
If you were doing that problem, but you had, for example, the equation you have there to the right with the potassium and zinc, if you're calculating the cations, would you like concentration of cations?
Well, he's not going to give, look, he only has 2 spaces, right? He's not going to give you anything like that.
Okay.
He's only going to give you the real easy ones.
Okay. Okay, will we ever need to be able to do that? Or?
For my quizzes, maybe. But I will probably say, what did I say? Concentration of cation. I guess you'd have to add them together. Okay. So you have 2x plus 3x is 5x.
Okay.
But I don't think I would do that. Yes?
Where'd you get the 28.1 over 0.1?
Where did I get that one?
Oh, 7.
Oh, this one. Yeah, that's a 7.
7.
70, that's, here I calculated the formula. Okay. So anyhow, the only reason I looked at his solution, he mostly rounded off. It looks like he only did 2 significant figures, really, but I would, you know, if he's doing that, you should probably enter the 1.1 volts and things like that. Okay, what's next, you say? Common ions and buffer solutions.